Welcome. So today we're going to be looking at set notation and Venn diagrams. So just as a reminder, if we have A, and we're saying that A is a set of numbers, it just means that it is a group of numbers. So it might be 6, 8, and 10. The even numbers bigger than 5, up to 10. So you can kind of see that this is just a simple set. What this means is that A is equal to a set of numbers. So this itself is the set. So we can now say something like 6 is an element of A, where this symbol here means in or an element. And so we can think of this set as having 3 different elements, 6, 8, and 10. So these are a couple of the symbols we might be using. So we might say A is equal to that, and then B is equal to, say, 2, 6, and 9. And now we could say, well, 8 is not an element of B. However, 8 is an element of A. So E symbol there means an element or inside. So 6 is in A, 8 is not in B. Alrighty, but now we need to live inside a world, and the world we're going to be living inside of is called Xi. Now Xi, the way you draw it is you draw a little loop, and then you draw an E, and then a little tail. So loop, loop, E, tail. That's Xi. Now Xi is basically it is the mother set. It is the set that has everything in it. We call it the universal set. And it's called Xi, X-I, Xi. And so in this case, Xi, the universal set, is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And so we could say something along the lines of that, well, 3 is an element of Xi. Now, you might be wanting to say something like, is B an element of Xi? But remember, B is not a number. It is a set itself. So we use a different notation here, which is the subset notation, which is a U with a line. Generally, we're just going to use the U, which just means that it is a subset. Basically, that everything that B has is inside of Xi. Alrighty. So far all we've been talking about is set notation, and we've learnt a few little pieces of information. So we've learnt about Xi, we've learnt about the curly brackets as being ways of containing sets, we've learnt about elements, we've learnt about an element of a set, or not an element of a set, or even a subset. Where we want to go from now is actually drawing a Venn diagram to represent this. So the first thing we do whenever we're doing a Venn diagram is we're going to draw ourselves a box. Now the box needs to contain all of the elements of Xi, and in fact we often draw Xi as the label of the box. Every single number in Xi is going to appear in here. It's the universal set. Everything goes in there. So the numbers 1 to 10 are going to all appear somewhere inside this box. The question is, where are they going to appear? So let's draw 2 circles. Each circle is going to represent one set, either A or B. So let's label this one on the left with A, and this one on the right with a B. So what are the elements of A? Well, it's 6, 8, and 10, and the elements of B are 2, 6, and 9. But obviously 6 appears in both. So rather than putting it in either spot, we're going to put it in the middle because it is included by both. Then all we need to do is put the rest of the numbers in. So 1 hasn't been placed yet, so it's going into the open space. So this whole area, the opposite of this area. So if we go through here and we think about the C of this space, all of this space here, well, that's in either an A or B. So 1 isn't in A or B. 2 is in B. 3 is in neither, so 3 can go into here. 4 is in neither. 5 is in neither. 6 is already been accounted for. 7's in neither. 8's in there, 9's in there, and 10 is in there. And so now you can see I've got the numbers 1 to 10 shown in a Venn diagram. Alrighty, well, let's talk about some other notation that comes around. And these are two really key operators. We have the AND operator and we have the OR operator, or the intersection and the union. So the intersection symbol is this. So A intersection with B, A union with B. So the way we read this is we read this as a intersection. Whereas this we read as union. Okay? Notice the N basically means intersection and union because it's a U. So an intersection means all elements that are shared. So the union set, well, there's only one thing that is shared by A and B, and that's the number 6. It's the only one that is shared by both sets. A union, on the other hand, means that we are joining these things together. So it means we want everything from either or. So in this case, everything that's highlighted is going to be in there. So that's 2, 6, 8, 9, and 10. It's the joining of these two. We sometimes read the intersection as and, as in is in A and is in B. Whereas union means or, is in A or is in B. They're different ways of reading it. Last lesson we talked about the opposite, or the not set, so we can have not A. So not A would be equal to everything that is, well, not in A. So if I highlight A, everything that is not highlighted would be not A, which is 1, 2, 3, 4, 5, 7, and 9. Everything else is highlighted. If I wanted to do not B, well then I would first want to highlight B, and then think about, well, not B is going to be everything else. So it's 1, 3, 4, 5, 6 is in B, 7, 8, and 10. But of course I could go even one step further. What is the intersection between, let's say, A and not B? All right, so what's the intersection? So let's go with A first. So A is this area right here. And let's color in not B in a different color. So not B would be everything in here that isn't in that circle. That green area there, that's not B. So in this case, A, well, A is just equal to 6, 8, and 10. And the operation we're doing is the intersection. And we're intersecting it with the set of not B, which we worked out before is 1, 3, 4, 5, 7, 8, and 10. Intersection means where we share things. So 6 is not shared, so 6 isn't going to make it. 8 is shared, so 8 is going to appear. 10 is shared, so 10 is going to appear. And that is going to be the intersection. If instead this was a union, then we'd be getting everything, but we would ignore any duplicates. So that is a little bit of set notation and a little bit of dealing with some more interesting questions to do with Venn diagrams and sets. I'll see you in the next one. Goodbye.